This is a project on related rates. Related rates problems find the rate at which a quantity changes by using the values of known related rates.
So pull. Yep. Okay, stop. Backwards. Place. And then. Oh my god.
A 5-foot Genevieve runs towards a 12-foot street light at a rate of 5 feet per second. At what rate is the length of her shadow changing when she is 3 feet from the base of the post?
As you can see, Genevieve and the lamp form two similar right triangles. Their height and their distance from the tip of Genevieve's shadow are related through this proportion. Cross multiply to get 5L equals 12S.
We know that L equals S plus the distance between Genevieve and the lamp. However, since 3 is not a constant value, like the heights of Genevieve and the lamp, we will use x in our equation. So we will substitute S plus x into L. Do some manipulation and you get 5x equals 7s. We get the derivative of both sides in respect to time t and get 5 dx dt equals 7 ds dt.
We know that dx over dt is equal to -5, the rate at which Genevieve runs toward the lamp. We substitute this value in, then solve for ds over dt, and get -25 over 7 feet per second, or -3.571 feet per second.
Oh man, Amy, help! The comet's coming.
那个邪恶的生物再次醒来了，勇敢的战士，你需要用我的魔法气球来击灭它。
Air is being pumped into a spherical balloon at a rate of 5 centimeters cubed per minute. Find the rate at which the radius of the balloon is increasing when the diameter of the balloon is 20 centimeters.
Here, we are given the values of the rate of the volume of the balloon and its diameter. We must find how fast the radius is changing.
We use this formula for the volume of a sphere, find its derivative, and plug in all the known values. The balloon's radius is changing at a rate of 1/80th pi?
80th pi. Just record the last part again.
At a rate of 1/80th.
The whole line.
Okay.
It's 1 over 80 pi.
Ah.
I probably should have written out the word over or something.
The balloon's radius is changing at a rate of 1 over 80 pi centimeter per minute.
Be gone, demon! Okay, I hate you. Take off your mask. Okay.
I'm the real, I'm not the real.
Yes, you look magnificent.
Jesus, get away! I can't handle it. I'm gonna win.
He gets into lots of different interesting roles. Where's your...
Lemon.
Oh no, where'd she go? She's been flattened into a paper. Where the hell did she go? I'm trying to look it up, and it's not going up. Wait, turn to the side.